Hello everyone, thank you for coming along to my talk. My name's Rory Thomson. I'm the Director of Engineering at Pocket Sized Hands, and I'm here to talk to you today about porting without the pain and how you can set up your Godot game for success when you're looking at getting onto other platforms, whether that be mobile, whether that be consoles. So yeah, to give a little bit of background about Pocket Sized Hands, we are based in Dundee in Scotland. We are approaching our 10th birthday as a company, which is pretty scary to say. And we specialise largely in doing work for hire, kind of co-development, and do a lot of porting work as well. So here's some games that we've worked on in the past over on the right-hand side. And yes, I did some number crunching recently because 2025 was quite a year for us in terms of shipping stuff. We shipped 29 releases last year, which is, when I say release, I mean if a game shipped on Nintendo Switch, it released on PlayStation, I would count those as 2 releases, but it was 7 titles, 29 releases, and 8 different platforms, which when you think about it is more than one every 2 weeks. And we are 14 people, so we did a lot last year, and a lot of work in and around porting. So yeah, a lot of the work that we've done in the course of the studio has been Unity and Unreal Engine titles. All of these games that are up here on the right-hand side are Unity and Unreal games. So you're probably wondering why I'm here at a Godot conference, and that's because we're working in Godot now and we're porting games in Godot. So I wanted to come here and talk to people about Godot and learn what people are doing and speak about what we're doing and get to meet people. And it's been amazing so far, and I'm excited to meet more of you today as well. But yes, looking at what we're actually doing in Godot at the moment. So this is a game that we're working on at the moment. It was developed by a studio called Smitner Studio. Smitner was supposed to be here at the conference, but he couldn't make it, unfortunately, so I'm here singing his praises and talking about his game. But the game's called Hazard Pay, and it's a puzzle block pushing game. So you're in this kind of facility and you've got to go clean up all these different rooms in the facility that have been blood-stained and have all sorts of ominous things going on, but you've got to solve the puzzles in a particular order. So what we're doing on the project is the ports for the Nintendo Switch and for the PlayStation 5, and it's being published by Numbskull Games as well. So we've been asked to come aboard and do the porting work, and yeah, it's a really exciting little game, really cool. If you've not checked it out yet, it should be coming out in a couple months' time, and it'll be on PC, on Steam, PlayStation 5, and on Switch as well. So check it out. So I want to talk a little bit about the agenda for today as well. What do I want to kind of share? Obviously, like I mentioned, we've been working in this space for around about 10 years now, and what kind of things are we like talking about doing when we're saying we're porting games? Like, a lot of that's applicable lessons that we've learned through working in Unity and Unreal, but it's not necessarily things that apply only to those platforms. It's general lessons that we can apply to everything. But then also looking at how these things actually apply to a Godot project specifically. I think in terms of what we do as a studio, we have a unique perspective on the game development cycle, I think, in my opinion anyway, which is I'm sure everyone's been in the position where you've developed something yourself and you get to the end of whatever you're building and then you realize, actually, I would have done it completely differently if I was to do this again. Like, everyone's been there. And with what we do, we look at projects in an accelerated time frame. We take on a project when we're doing a port anyway, quite often at the end of the cycle. And we are dealing with the consequences of the decisions that people have made in building their games and trying to get it to run on other platforms, which can sometimes be a grueling thing. In a lot of ways, it can be a really good thing as well, because you're like, whoa, I never really thought about doing something that way before. That's really cool. But you experience these things, and you experience the consequences of the decisions in a really quite like an accelerated time frame, because you're working on the port, and the port's not taking multiple years for you to make, unless the game's like absolutely crazy. So yeah, like looking at it through that lens, we make lots of lessons learned in looking at lots of different projects, and kind of that feeds back into how we actually look at the projects when we're looking at something new. We've got what we kind of refer to as a health check internally, which is maybe sounds a little bit clinical, but it's like it's basically kind of a culmination of all like the lessons we've learned throughout looking at all the different projects that we've ported, and it's kind of just a general checklist of here's things we might want to think about. And obviously every game is unique. There's going to be different things that affect different games that might not be applicable to other ones, but it's generally just to kind of try and keep us right and make sure that we're thinking about all the things and all the things we need to be thinking about. So I'll talk through the health check today, and I'll talk through a kind of a practical example in Godot about how do we actually specifically how specifically does that apply to a Godot project? Like through the example we'll look at, it'll be like if I've got a game that's running on Steam, how might I want to actually architect that in Godot so that if I want to put it on another storefront, I can still have the same functionality, if you know what I mean. One thing I just want to caveat before I go into talking about all of this is like premature optimization is the root of all evil, as everyone knows. Like these are things, and my hope is that you can kind of take away and start to think about some of these things in your own games, or to like look at these kind of things through your lens of your own game, and like you don't necessarily need to action them, because I think if you've already probably got enough things in your head whilst you're making your games, if you know what I mean, like you don't want to add more things to the never-ending list of things you've already got to do, but it's just, I think, useful information to kind of be on the same page with. Optimization and performance. We quite often, when we're looking at a project, take a step back and try to assess, like, at the widest perspective we can see, like, what are the things that we need to be thinking about. So when we're looking at a project, it's like, what is it actually even possible to do the thing that we're trying to do? And it's usually always possible to port a game to another platform, but it's a question of cost as well, right? How long is it going to take to do the thing? And quite often, if something's going to take far too long to do, then it's just not applicable. Like it can't happen, type thing. As unfortunate as it is, that's the reality of the case. But when we're looking at kind of optimization, what we often look at when we take on a project at the assessment stage, so this is before we're actually doing any work. This is just speculative. We'll do what we do, like a cold port of the game, which is just a quite an aggressive going in and making changes in the code base just to try and get the game running on target hardware. Usually we try and take the what is the lowest target. In most cases that's the Nintendo Switch, and we try and get the game running on the Nintendo Switch by all means possible, regardless of what we have to do and regardless of what corners we need to cut in making that happen. And we try to make learns from that. So what are the really difficult things that we've identified in doing that we're going to actually have to fix properly when we do the port? What are the kind of worst case scenarios in the game as well? Both in terms of like, if the game can be really simple but still be quite complex on the CPU side. Like let's try and figure out if we can, I guess, exploit the game to get the worst possible case scenario that a player can encounter from a CPU load perspective and from the graphics side as well, and figure out, like, from there, what are the things that we're actually going to need to be thinking about when it comes to porting the game. So as a developer, like if you're looking at your game, it's good to have an understanding as to what the worst case scenario a player can encounter when you're making your game. And kind of leading on to that in a similar vein, but not exactly the same, rendering. Like when we're looking at Godot, Godot's got multiple render paths in it. It's got the forward plus renderer, it's got the mobile renderer, and it's got compatibility renderer. Like, which one of these are you using in your game, and what features from it are you actually using for example, like if you're using the forward plus renderer, there are a lot of features in that forward plus renderer that are not applicable on other ones. And if we want to get your fancy effects that you're using from the forward plus render running on a Nintendo Switch, realistically, we're going to need to be thinking about how can we create fallbacks that if it's a particular visual style thing that you're trying to do with any of these features, how can we try and recreate that? Because we want to be able to make the Nintendo Switch version of your game like on par, if on the same level as your version that you've got on the PC, if that's kind of your primary target platform. So thinking about fallbacks from that perspective, but then also if you're using quite a lot of like visual effects and things like that, we might need to create like kind of fallbacks for those instances as well, for lower target hardware. Asset management is quite often one of the key things that we encounter when we take on a project, when we're looking at porting it to other platforms, and we often see problems in. If your Godot game boots into the entry scene and that entry scene has like hard references to all of the other scenes that your game's going to load, effectively when you boot up your game, you're loading in the entire game's content in some cases at that initial loading screen, at that splash screen, which might be okay on PC, but then on other platforms when you're looking at lower power, whether it be mobile, whether it be Nintendo Switch, like that kind of time that you take to do that initial splash screen is extended quite a lot, and in some cases could result in the game failing certification if it takes too long. Looking at things like asset management as well, it's one of these ones which can be particularly difficult to unpick in situations. If there's logic that's baked into your game, which is built in such a way that the game expects something is going to be there, like I don't know, like an enemy scene that you're going to spawn in. Like if the game just expects that that's going to be there, and you cut that connection to make it into something that gets asynchronously loaded at runtime, like that can, on a surface level, be an okay change to make. But there's so many implications to making changes like that aren't always entirely visible at first, and so they have cascading effects if we make changes like that. In order to kind of cut down on like runtime memory on a game. And yeah, like a lot of times when we're working on games, various different games, like we run into memory restrictions, like on particularly like Nintendo Switch, run out of memory quite quickly if the game's not been optimized and doesn't have a good system in place for asset management. So thinking about your game through the lens of what do I actually have loaded at the moment? Because it's a very easy thing to not think about until it's a problem for you, but it's a very it's a very difficult thing for you to then unpick at the point where it is a problem for you. Looking at the kind of controller input side of things, like how's your game being designed from a controller and input perspective? Like, is your input scheme compatible with the target platform? A lot of people develop games on PC and they use keyboard and mouse to interact with their game, and naturally with that you end up with games that are more tailored towards input with keyboard and mouse, and you might not actually even have gamepad support. So we need to think about how do we refactor the design of your game in some cases to be compatible with the gamepad. Similarly, if we're looking at mobile, like that's a similar consideration. Is it like touch input on mobile? Is it even the case where there's a lot of games that are still preferable to play with the gamepad, so you probably want to have gamepad support on mobile. And again, kind of this is one of the key things when we're looking at games in ports that we look at is a problem area, because what can end up happening is usually what we do as well when we get a game in is we hand it over to the QA team in the studio, and they will go ham and break the game almost immediately just by spamming buttons, because there's unhandled cases in terms of should the user actually be able to press this button at this point in time type thing. Probably not, or something unexpected happens. So there's things like that. And then looking at like iconography swapping as well, like when we plug a PlayStation controller into your game, do we display PlayStation glyphs on on the system UI if that's in use? Do we display Nintendo Switch glyphs when a Nintendo Switch controller is plugged in? These are things that we need to do to get the game through cert on those platforms, because they won't be happy if you submit a game to Nintendo with PlayStation buttons in it. And localization and terminology is another one. I think it's one that seems like quite obvious. You'd be surprised about how many projects we've worked on where there's either non-standard localization systems in use, localization systems not used at all, and like localization systems that just are like custom, are bespoke to the project type thing. And you know, localization is one of those things that at the early stages of the project, when we're working on something, we need to be quite diligent about making sure that we are having conversations about it and identifying things that need to be localized, whether that be specific strings in the game that we need for to submit the game into console certification and things like that. There might be key terminology which we need to refer to things as when we ship on console, like a controller might not be a controller if you ship on Nintendo, and it might not be a controller when it's shipped on PlayStation. You might need to refer to the hardware as different things, and so we need to put mechanisms in place to account for those situations in your game code, and it also needs to translate to other languages as well. The other thing to highlight about localization is it takes time to get text localized, to get it back into the game, and it's not something that you can leave to the last minute. Like, we need to do it at the outset so that we're kind of identifying problems and making sure that we're catching the issues there and then. And then another kind of key area that we see identify problems with is like in the serialization and save systems in games quite frequently. You know, if the game logic's been built to expect instant reads and writes to disk, like sometimes in situations that's not a possibility on the target platform. Like we might need to do asynchronous saving so that we don't end up causing stutters for the player at runtime. And those can often be situations that are quite difficult to unpick as well. Thinking about like if your logic expects to be able to read and then instantly have that data available, loads of different systems in the game might expect to have that data there just immediately because that's the way the game's been built. Again, it's similar to like the asset management thing I was talking about earlier. If you make that change, there's all sorts of kind of cascading effects that can happen throughout games when you make changes like that that you need to account for. Too many save files as well. Like if you've got like, I'm pretty sure I've worked on a game that had 5 different save files for different things at one point. And like those types of things, what they lead to is you end up doing really frequent reads and writes to disk to save and load those 5 different files. And that can be problematic as well. And we quite often need to look at consolidating data into one file to make sure that we're compliant with whatever platform that we're targeting. Audio, we've had experience with projects where like there's a reliance on audio middleware, and we need to be kind of conscious of those things up front. Like we don't have dedicated audio in-house. We've worked with partners to kind of assist in those situations. But if there's a reliance on audio middleware and there's a risk there in terms of us not having the expertise in-house to be able to do that, then like that's something that we need to consider up front. As well as that, like, how has the audio been developed? Has it been developed by somebody with expertise in the audio field, or is it developed by somebody who's kind of done it off their own back as like a kind of ad hoc approach? Because what we've often found in terms of when we take that kind of stuff to consoles is if they've perhaps not done like the best job, they've done as good a job as they can to get it working, but we can often encounter issues with mixing on the consoles and in terms of audio loudness. When we're looking at things, so we need to go in and then refactor so how some of the mixing's working in the game to get it functioning properly. Talking about like UI as well, like is your game UI compatible with the platform that you want to look at it on? Like developing on a 4K large monitor is one thing. Like what happens when you put it on a Nintendo Switch size screen at a 720p display? What happens when you take it down even further to a mobile screen, which is maybe higher resolution but smaller? Are things actually legible in your game, or do we need to think about redesigning things as well? It could be the case that actually it might be the case when we were looking at the UI, like we can redesign things so it's compatible with all platforms that we're looking at, but it might be the case where we actually need to make some extreme modifications and redesign elements of the UI that might display on a smaller screen. Navigation and state handling, like I talked about controllers, controller input, and like what we look at with those cases in games where input state's not necessarily handled effectively, leading to like players being able to do things they shouldn't be able to do in certain menus. UI is like a key place that we see this happening. If players can still continue to like move their cursor around when they shouldn't be able to, when there's animations playing and things like that, it's really, really frequently a problem for us in terms of like people being able to just completely soft lock games if it's not handled properly, or ending up moving the focus of the cursor onto some UI element that's not even displayed on the screen type thing. And there's heaps and heaps of other things that we look at on projects as well in the health check. And like I said, it's a case of looking at the game at taking a step back and looking at the game from a wider perspective and understanding what kind of things do we actually need to think about here, like, because there's online features as well, like that's a whole other kettle of fish that we need to think about, but kind of these other things that I've been talking about thus far are generally applicable things that we'd be thinking about. Like DLC as well, like it's not really applicable to all games, but there are instances where it is a thing and we need to think about. So the other thing is like scripting. When we're looking at a project, we do take a look at the code, and we do an assessment of the code to understand, is it going to be straightforward to work with? Is there going to be problems? Has it been architected sensibly, or do we envision having any difficulties working with the code as it's been implemented? There's a lot of different options for implementing your code in Godot. I didn't actually realize until I was writing this talk how many there were. But yeah, like obviously they've got the kind of primary supported things, GDScript, C#, and GD extension. You've got all these other ones that are maintained by the community though, which is just absolutely bonkers. I think like in our experience and from our perspective, GDScript is built for the engine. It's the best supported one. Like you effectively, when we're looking at, like, for example, our PlayStation 5 port, you get it for free almost because it's ingrained within the core of the engine. C#, for example, like it's becoming more and more popular in the engine as it's been introduced. It's reliant on the .NET runtime, and it's not necessarily compatible with all targets that you might want to get that running on. So it's not necessarily for free. If you're building your game in C#, there might be more difficulties that we would encounter when we look to try and take it to a platform. They've got some notes on the Godot docs about like the actual platforms that the C# implementation supports, but just be aware that it's not something that is just for free. Nothing's for free. GD extensions as well kind of sits in a similar boat as C#. Like it's again, it's not for free. If you want to write a bunch of your game code in a GD extension and we want to ship it to a platform that the engine doesn't natively support, there's work there in terms of we need to compile the binary for your GD extension for that platform, and we need to link it in, which isn't it's additional things that we need to consider when we're looking at scripting. But yeah, kind of talking a little bit more about scripting, like I said, a bit of a practical example about how we might actually deal with a situation where we're looking at Steam in a Godot game in GDScript. So let's say for hypotheticals, we've got a game manager here, and on ready, it just unlocks a Steam achievement. That's all it does. Very simple. Happy days. It's got a Steam add-on, and in the plugins for the editor, it's got the Steam plugin enabled as well. And when you run, it unlocks the achievement on Steam. Happy days. What happens when we want to do this on another platform? How do we architect the code in a way that if I want to have Epic Games or Google Play services or any other platform, how would we actually do that? So we've got our export target for our Windows build. Let's just say this is the one that we've got for default just now that we're exporting to Steam. like that'll work for now. But what we want to do is make use of feature tags. If you've not heard of feature tags, or if you've not used them in the engine, this is kind of a primary mechanism that we've been utilizing to do some of this stuff in the work that we've been doing. So I would add a feature tag to the engine for Steam. And what you can actually do, just down here at the bottom, is you can override settings, if you weren't aware, for feature tags. So I could say only have the Steam plugin enabled when the Steam feature tag is in the target that I'm trying to build. And what you end up with is an error. Because now when we export the base build, like if I go back again, we've got two exports now, one which is for Steam and one's for Windows. The Windows build now complains because the Steam plugin isn't there on the base Windows build. So from there, let's look at abstracting that implementation so that it's not a problem. We make two classes, a base platform class, which is just the generic implementation of a platform, and we create a Steam platform as well. All it does is just have two functions, platform name, get, and an unlock achievement function as well. And if we look at this big, I'm glad the projector's so big, by the way, because I was worried about how legible this text would be on the screen. So like if we look at this kind of example here, kind of get platform type being the first function up there, we can check that feature tag again to see if Steam is enabled, and if it is, then we return just the Steam from the enum list. And then in the enter tree function, like you can see that depending on which platform we've identified that we're running on, we instantiate the appropriate platform class, which is the one that we defined earlier. So if we're running on Steam, let's instantiate the Steam platform. If we're running on just the base Windows build, let's instantiate the platform base one. From there, we need to make some changes to our game manager. So instead of calling Steam.unlockAchievement, we just call platform.unlockAchievement. And now, when we look at our Windows build, like our base one and our Steam one, they both work, and they both do the respective implementations. And that's kind of like the core principle behind like a lot of these things when we're looking at different platforms and different feature sets for different platforms at the moment in Godot games. And like it's something that's applicable to this situation. It's applicable to many other though. Like let's think about, again, if you want to ship your game on the Epic Games Store and you want to support Epic Games Store achievements, like you make an Epic Games Store platform and you implement the appropriate functionality for that. Same with Google Play, same with if you want to do any other console platforms or anything like that, similar approach there. It's applicable to other things as well, like I mentioned earlier, there's considerations around swapping terminology out on other platforms, and so you could just call into a platform get terminology string and you'd get out the appropriate terminology for that thing. So again, it seems really obvious, but these are the kind of things that we kind of think about when we're looking at porting these projects. And like UI specialization as well. So yeah, I think that about covers things for it. Like those are some lessons that we've learned and through doing what we do. And yeah, I think I'm very happy to talk more about it through the lens of your game if you want to come and talk to me about your game. And I'm very happy to just talk about Godot in general and Godot on consoles and so. Yeah, thank you very much all for listening, and yeah. If you want to add me on LinkedIn or reach out to me, my email's here and my LinkedIn QR code's there as well. So yeah, thanks all. Any questions? Yeah.
Hi, thank you. Amazing talk. I was wondering, because I don't think you've touched on that particular part so much, how is your pipeline? You know, are the developers developing and then testers are testing all the platforms and coming back with all the nodes, or how does that work?
How do you mean in terms of all the nodes?
Notes, as in just like, oh, this doesn't work on this platform,
notes,
this UI.
Sorry. Yeah. So generally what we do in house is there's like a phase of a project where we usually get a project in from a developer, and then we'll start working on it from there. And if it's a porting project, that'll be the primary objective will be getting the thing to run on the target platform and then integrate other platform features. So as soon as we've got a version of the game which can run on the platform that we're looking at porting to, then we can hand over to usually our QA department in the studio, and they'll be the ones that are testing, and then they'll come back to us and let us know what they've found in the particular build that we've sent over. And then from there, there's a prioritization that needs to happen between the continued development of the port and addressing the bugs that they've identified as well through that process, because there was always bugs.
Yeah, I mean, and one bug creates another bug.
Yeah, absolutely.
Last question.
I'll speak to you after.
Okay. So I think in the beginning you mentioned that sometimes the cost of porting is much bigger than the benefit of porting. Mm-hmm. And then you mentioned a bunch of things that contribute to that cost. So if you have to, is there like a top 3 that contribute to that cost, or is it always a mixture of the accumulation of all of these small things that...
Yeah, I feel like it's a bit of a cop-out answer to say that it's a culmination of all the things, but ultimately it is. Like, I think there's definitely things that turn it from an easy ask into a more difficult ask, particularly when we're looking at through the realm of like doing multiplayer. Obviously, the complexity. This is gone. No. Sorry, I just cut out for a second. The complexity of developing a multiplayer game is a lot higher than developing a non-multiplayer game. The complexity of developing and shipping a multiplayer game on loads of different platforms is like, it just increases type thing. That certainly feels to me one of the most like key examples of where there's a significant like, if as soon as a game's multiplayer, this is going to take a lot more for us to do. I guess like to your point, in terms of in the general case, like it really depends on a number of these different factors that we take in the health check. Because if there's particular problems around asset management, like, and the game's been designed in such a way where it's integral to the way that the game works, like it's all situational, and that might mean that in order to get the game needs all these assets loaded all the time because of the way the game's been designed, like we need to deal with that. But then it's like the cost to deal with that is probably going to be a bit higher, if you know what I mean. Like it's going to take more time to fix that.
Thank you, Rory.
Thank you.